Click the bell icon to get latest videos from Ekeeda.
Hello friends, welcome to Ekeeda. Today we will see how to solve problems on two-port networks by using KVL or KCL. Let us go to problem number 1. Here you can see we are supposed to get transmission parameter for the following network, and that is also by using either KVL or KCL. So if we want to use KVL here, you have to take currents I1, I2 and I3, but already you can see I1 is defined and I2 also is defined. What we will do now is we will take this loop and call current as I1. I will call this current as minus of I2, because this I2 is going to my left and my I2 is going to right, so this is minus of this, and this current will be called as I3. And now by using mesh analysis we'll get three equations, and maybe by substituting few terms we'll get the answer. Remember, we have to get transmission parameter. Maybe it will happen, or we will do in that way, that we will get equation something like this in V equal to Zi form, or we can say V1 equal to Z11 I1. Why Z11? Because all these are resistances. So Z11 I1 plus Z12 I2 and V2 equal to and once we get the voltage equations, anyway we are applying KVL, so we will get voltage. In fact, when we apply KVL, we do get Z parameters. This is the conclusion. So we will get the Z parameters, and once we get Z parameters, by using the conversion formulae, we can easily get transmission parameters, that is T parameters or ABCD parameters. So let's solve these loops. So I will apply KVL to loop number 1, loop number 2 and loop number 3. So by KVL to loop number 1, it should yield me V1 minus 15 into I1 minus 30 into I1 minus I3. So let's write that equation, then we'll write equation for loop number 2 also. So this is the equation that we have got by applying KVL to loop 1. Now we will apply KVL to loop number 3. In fact, we are calling this as loop number 3, but we should call this as loop number 3 because this current is I3. So we'll call this as loop number 2 only. So we'll apply KVL. If I'm going from plus to minus, it is minus of V2, then minus of 30 into minus I2 minus I3. This current is minus I2, we don't have to forget this, and then minus 10 into minus of I2. So this is our equation number 2. And now you can see V1 and V2 I have got both, but I have got in terms of I1 and I3, whereas I should have got it in terms of I1 and I2. So somehow we don't need this I3. So for that we'll apply KVL to loop number 3. So loop 3 means this one. So here what we'll get is minus 30 into I3 minus I1, then plus 2.5 V1, then plus 2.5 V1 and minus 30 into I3 minus of I2. That will be our equation. We have to get V1, V2 in this form. So let's try. So here we have got this V1 equation now. Now this V1 equation has I3, I1 as well as I2. We have got one more equation of V1. If you see this equation number 1, here also we have V1 equal to 45 I1 minus 30 into I3. So in this equation, if we substitute V1 equation, then first of all V1 will not be there and we will get I3 in terms of I1 and I2. So in this equation, if we substitute V1 equation, then this will become in I1, I2 and I3. So we can write I3 in terms of I1 and I2, and that is our aim. So let us substitute the value. So this is the value of I3 that we have got, and now this value of I3 we can substitute in respective equations and we will get V1 and V2 equations in terms of purely I1 and I2. For example, right now this I3 is in terms of I1 and I2, and if we substitute it here, we will get here I1 and I2, and now our V1 will become in terms of I1 and I2, and that will solve our problem. So after substituting the value, this is what V1 we have obtained. Similarly, we will get V2. So now again by substituting for this I3 which we already got, we can get value of V2. Now this value of I3 which we have obtained, we will substitute in equation 1 and equation 2. That means this equation as well as this equation of V1 as well as V2. I3 now is in terms of I1 and I2. So once we substitute it here, our V1 and V2 will be in terms of I1 and I2, and that is our aim. So after calculation, we have got V1 equal to 13.35 I1 plus 6.66 I2. Same procedure will be done to obtain V2. We will substitute the I3 value in equation number 2. So after again calculating, we got V2 equal to 31.665 I1 plus 33.34 I2. Now we will compare these both equations with original equations of Z parameter. That is, these are the original equations to define Z parameters. So V1 and V2 we have. Similarly, here we have V1 and V2. So V1 is Z11 I1 plus Z12 I2, and V2 is Z21 I1 and Z22 I2. So we have got Z parameters. So these coefficients or these values are nothing but Z parameters. But our job is not done yet, because we need transmission matrix or transmission parameters. So for that, we will use conversion. From this formula sheet, you can see that if I want to get transmission parameters from Z parameters, we need delta Z, then remaining parameters at Z11, Z21, all we have. So just by calculating delta Z and substituting the values here, we will get transmission matrix. Continuation of video. Now for this parameter we need delta Z, and delta Z is determinant of this. So we can calculate that delta Z. 33.35 multiplied by 33.34. So for this parameter we need something called as delta Z, and delta Z can be very easily calculated from this Z matrix. So this multiplication of these two terms minus multiplication of these two terms. So delta Z is 234.01, and finally our matrix is so these are the values which we finally get, and that is nothing but our required T parameter or transmission parameter. So that is the end of this problem. So thank you very much guys for watching this video. Stay tuned to Ekeeda and please subscribe to Ekeeda. Thank you.